So I think in the original schedule, we had 15 minutes allocated for QA. We are running a little bit behind. Is it okay if we, okay. So I think the idea is to open up now the table to questions related to first to this last session, but then to also the previous session and everything that the conference discussed. So maybe let's start from this last session. So any go backs that anybody wants to bring in from these talks? Oh, yeah.
So this question is going to Casey and also William as well. So, okay, hey, so can you say a little more, little about the most problematic false positives? I mean, these like sources or phenomena for those, in your case, like a black hole microlensing, and also for William, like a free floating planet microlensing.
So the question is false positives for black holes?
Possible, the most problematic false positives for your case.
I don't know if there's necessarily a false positive in that like the event is so long. It's like that will, I think we can pretty confidently say it will be a microlensing event. It's sort of like distinguishing whether it's a black hole or a star. For that, you need to have a good mass measurement. So maybe I would say I'm pretty sure false positives will not be a problem. Like we will know this is a microlensing event. The question is how well we will be able to constrain the mass given the coverage of the event.
There is another question. Yeah.
I think the most concern is the whether any systematics on the photometric parallax measurement in the light curves that can be affected by the low level systematics than the astrometric, I think.
Or I guess one thing that we found in ZTF microlensing that is less of a thing in the galactic bulge, but if you do find microlensing events elsewhere, sometimes quasars can actually masquerade if you have the photometric signal only, since, you know, if you sometimes they can be flat for a really long time before or after a signal, and if the signal to noise isn't great, sometimes they can disguise. But in the galactic bulge, that's less of a concern.
Anybody else wants to contribute to this particular discussion or to comment on the session or have any questions about microlensing for black holes? Okay, so maybe we can move on to the previous session, which was about the exoplanets. I think Takahiro is a, yeah.
I is very general, so
oh,
anyone has a specific.
Okay, let's see first if there is anything about, oh, Natasha? No? Let's see. I don't see any hand up. Okay. So
all right, I go ahead. So I've been wanting to ask this question for a while, but John this morning, introduced CZI very detailed. So a random question came to me. So what does WFI instrument do while the CZI is in use in the mission? Is that completely occupied, or is there any?
So let me make sure I understand the question. The question is, what is WFI doing when CGI is being used? So the primary things WFI does when CGI is used is it acts as a guider for the telescope, for the observatory to stay on target. We use the WFI focal plane to do guiding and feed into the ACS system to hold precise pointing. At the same time, you could imagine that whatever field you're pointed at, and you're using those guide stars to do guiding, you could also just take wide field imaging data while you're there. You could imagine that happening. I don't want to make a claim that there's a plan to do that right now, but there is. Okay. All right. So yeah, you get basically free data wherever you're pointing. The CGI and WFI fields of view do not overlap. They're adjacent on the sky because of the way the optical system is designed. So you won't get, data for the same field you're observing with CGI, which is very, very tiny compared to WFI, but you will get data with WFI while you're guiding.
So the degree of planning so far has focused on making sure that we have the flexibility to do things like choose filters so that you can make a scientific choice on what would be useful for wide field science while also meeting the coronagraph needs for fine guidance. We haven't yet thought about how those decisions would actually get made. It's a little tricky because we don't yet know what the coronagraph observations are going to be. But it seems to me that once we know what the coronagraph observations are going to be, then we can have a discussion about what would be the most useful use of wide field at that time.
Right. Yeah, given the numbers that John introduced this morning, extremely, I can think of extremely deep Roman field, next to the CZI target, and that could be an interesting project.
Yeah, it's just worth keeping in mind that you're probably going to have limited capacity to do things like dither and roll if the CGI is being used as the primary mode, right? So, yeah.
All right. Yeah. So my point was, if the observatory was perfectly rigid, then you could use the WFI data as an astrometric reference to get astrometry of the target that might give you masses of the planets.
I could speak to that a little bit. Yeah, Vanessa Bailey, I'm on the coronagraph instrument. Yeah, I think in a perfectly rigid body situation, the answer is yes. In practice, based on spacecraft thermal modeling, we expect drifts on the order of a few milliarc seconds per hour differential between CGI and WFI in ways that I'm not sure are completely deterministic. So I think that's what's going to limit our astrometric precision.
So this is a question online by Jennifer Sobek. Will WFI follow-up image and spectra will be taken for all CGI targets? And there is a second one. Is there any need to do so?
The question was, will there be spectra taken of all CGI targets? Did I hear that? In both. We will more often be taking images of targets than spectra of targets. So those are two mutually exclusive observing modes for the instrument. We will also on our fainter targets just be photon limited. And so spectroscopy may not be possible on the fainter targets. Also keep in mind that with a resolution of 50, and the wavelengths that we have access to, there may not be spectrally interesting features. Debris disk, R50 slit spectroscopy may not be something that's scientifically interesting. But yeah, I think it's worth keeping in mind that our nominal imaging band and our nominal spectroscopy band are also not the same. It's about 575 is our nominal imaging, and spectroscopy is a goal mode with a central wavelength of about 730. Okay, so the question was, what is the typical magnitude range for, I'll say, both host stars and the science targets? That's a good point. So our requirement, and the only thing we can vouch for at this point, is to be able to guide on V of 5 or brighter host stars, quite different than WFI. But with, yes, but we, with a contrast ratio of 10 to the 7 or 10 to the 9, we're getting down into the 20s.
So I'm sorry, but I think the question was specifically about WFI image of CGI target. Okay. It's too bright, Jennifer, sorry.
Okay. Any other questions, comments?
Just to go to the opposite end of the brightness scale, I've seen a little, but not a lot. Galaxies, but also mapping surface brightness, the structure of the exterior of galaxies. But I haven't seen a lot, and in particular, my impression from people who do this from the ground is that the limiting factors tend to be scattered light and not just pure noise. And so if anybody has been thinking hard about this and images and calculations, and if anybody's been thinking about the scattered light effects, I'd be very interested to know what people are finding and to what extent we're going to be able to forecast things about low surface brightness imaging capabilities before launch versus about scattered light and maybe just either that's coming now or
So I have a quick comment on that. There's a WFS team that's focusing on this, and Alex Borloff is working with the Goddard Stray Light engineers to create a detailed scattered light model to characterize that performance as part of the development of the pipeline.
Yeah, I'll also comment that in our first thermal vacuum campaign with WFI, we used our telescope simulator to place bright point sources at various places in the focal plane, because there's a lot of chip gaps and light shields over the wire bond areas, et cetera. And we had pretty strict requirements for mitigating any stray light from a bright source falling in a chip gap or elsewhere. So we wouldn't be sort of self-contaminating during a survey. And we didn't find any issues in those specific tests with bright sources pointed at, potentially problematic areas in the focal plane. So that all came out in the clear, I would say.
Back to the previous question regarding the sources in the WFI being too bright. This is maybe a question for Josh. Is it because the WFI is used as the guiding mode? Is it possible to use the guide windows, which are clocking much faster, to then go to brighter targets? And is there anything that's readily obviously wrong with that?
So I would say that right now we don't have any direct plans to obtain science data in guide windows. Doesn't mean we cannot. It doesn't mean that the hardware limits that. It's just we don't have any current plans to do it. And the guide window noise properties are different than the full science focal plane. And so if you had a science case that wanted very, very high cadence and you didn't care about higher noise, et cetera, I don't want to say it's infeasible. It's just there's not a current plan to operate in that way.
Would you expect any other things like, say, the other calibration effects, like say the dark, for example, needing to be specially characterized in if you wanted to use the guide windows for science mode?
Yeah, I would say that all of the sort of detector properties within the guide window need to be characterized and calibrated on their own. They're not going to carry over from guide window to full frame because the guide window is operated by a separate set of electronics in the detector. And so that, noise, linearity, et cetera, you have to think about that differently and do it your own calibration.
Okay, any last comment, question before we close the discussion? Okay, I don't see any. So thank you everybody for bringing up these last questions and comments. And then I leave Takehiro and Etienne giving us their.
Oh, yeah. Okay. Thank you, Rebecca.